we first did the halogenation of alkanes. So where an alkane becomes a haloalkane. So then the hydrogen was just substituted for a chlorine, and you get a haloalkane. Now we have hydrolysis, and we said there's two types of hydrolysis. Okay. The first one is where you start with a haloalkane and it reacts with a strong base. Now you need to know which are considered strong bases, but that strong base must be dissolved in water, otherwise it will burn the compound. Okay, and we said substitution must be mild, soft. So dissolved in water, and then this whole thing must be in the presence of ethanol or alcohol, and we must have mild heat. Then what will substitute? Let's look. Obviously the weird thing here, this weird thing is it's valency negative or positive, Bookie? Okay, this will split up like that. Liakwe, potassium. And Antoinette, hydroxide. It's one of those polyatomic ions that you have to go study. Okay. So, Bookie, what do you think will swap? Will the brome swap with the potassium or with the hydroxide? Why? Not an aldehyde, but close. But no. But yes and no. Okay, it is with hydroxide. Why? Because the negative and the negative will switch with one another. Because if it's the potassium, will bromine that is negative bond with hydroxide that is negative? No. Okay, so the two negatives will swap. Okay, so Liakwen, what is the to which series does the organic product belong to? Homologous series. The alcohols. Okay, because you see the OH. What's the name of that alcohol? Ethanol? Ethan, because there's single bonds between the carbon. Ethanol. They're not ethyl because it's not a side chain. Ethan. And you don't have to say one ol or two ol because there's only two. Okay. Then Antoinette, what is the name of the organic reagent? Say again. The organic reagent. Where will I find a reagent? Okay, and which one is the organic one? Organic is the thing that has a carbon in it. Inorganic has no carbons. So I want this one's name. How many carbons is there? 2. What's 2? 8. And what do we have between the carbons? So what's that thing called? Ethane. Okay, but then you see that. What's that called? Where does it go? So put it together. Is it necessary to say 1 bromo? Because if it's on the second one, it's going to be 1 bromo. Okay, so this is called bromoethane. Okay. Sharp. Now let's look at the second one. Same thing. Okay, again we must have an alcohol present. Everything must happen in the presence of alcohol. And we must have mild heat. Okay, so what's the difference between the two? This one we just had the strong base dissolved in water, and this one we just have water. Okay, but the same thing, oh sorry, here must be a bromo. Why did you not tell me? Okay, you were going to say. I'm just going to go check next door. Do the same reaction as above. Alright. So, did you do the same as above? Easy peasy. So that will again switch with that. And we have that again. And we have that. Okay, so that it is either hydrogen bromide or a bromic acid. Bromic acid. You can say hydrobromic acid, please. Then there's something else that I wanted to ask Bookie. Is the alcohol that formed in both scenarios a primary, secondary, or tertiary alcohol? Why? More. Alright. Then the last one that we're going to do today, when we start with alcohols, and they undergo substitution with a halogen compound. Okay, and we need heat. Right. So we have here again 1, 2, OH. And we need heat. Eliaku, what is the name of the inorganic reagent? Hydrogen chloride or hydrochloric acid. Do you remember that from last year? Alright, Then it's that thing that's going to swap with that thing because they're both negative, so they will swap. Oopsie, CL. Antoinette, what is the name of the organic product formed? Organic product. Where are you looking at? Product, which side is it? DS, thank you. Ethanol. Oh, do you see an O there? Where's the O? Here, where's the alcohol? It's chloro. Ethane. Eth because there's two, ane because there's a single bond, chloro because there's a chloro. Then, Liako, what is the name of the inorganic product form? And they actually love to ask that question as a type of trick question. Okay, so I'm going to stop there for today. Just a reminder, substitution reactions that we did now is when we go from single bonds to single bonds. Okay, and that will make sense in the next lesson.